This question is given in GATE 2013 and it is a true or false question. They are asking that, this particular FD set, is it the minimal cover of this? Which means, they are saying if you try to minimize it, are you going to get this? So you could either do it in one way, that you take this and you minimize it and you see that is, you get that, or you can use the other way. So what is it? Both of them should be equivalent, which means this one should be covered by this and this one should be covered by this, right? And moreover, it should be minimal. So first let's see if they are equivalent or not. Maybe if they are not equivalent, there is no need in checking for the minimality also. So minimality has to be checked after equality, isn't it? So let's say if they are equal, let's see if they are equivalent or not. Let's see if all the productions of this set are covered by this particular set. Definitely this one is covered, it is clearly there, and this one is covered, it is there. And what about this one? AB determines it is not there, which means let's see if this one is covered by that. So how can we get it? We have to find out AB plus here and we should get E. In that case we can say that this particular FD is covered there, right? So if I see AB plus, using this set I get AB, that's it. I think I don't get anything else, right? I just get AB, which means this one is not covered by this, so both are not equivalent. So here itself we can stop and say that both are not equivalent. Got it? So maybe the answer is false, both are not equivalent, and therefore it cannot be the minimal cover of this. First of all, both of them have to be equivalent, then only it should be minimal, and then we can say that it is minimal cover. So since they are not equivalent, we cannot do anything further. So now what I want to see is, let us see if I could minimize it. See, already this one and this one, these three productions are there, and only this one is not there, isn't it? Right? Anyway, all the right hand sides are containing single attributes, so it is in already the first step is over, which means the right hand side are single attributes. Let's see the second step. So what is second step? Let's see if any of the productions are redundant. I am trying to minimize this one. Okay, let me see if any of these are redundant. So without this, let me see if AB plus is going to derive C without this. Now what is it? AB plus will contain, without this, one is AB, and because of AB I get E, and because of E I got C. Therefore without this I can get C. So this turns out to be redundant, so it is not required. Got it? And now let's see this one. Without this, if you could get E using D. So without this, if I find out D plus here, I get only D, I don't get E, so it is required. And without this, if I can get E, so without this, if I write AB plus, I get only AB, right? I don't get E here, isn't it? So what about this? Without this, if I write E plus, I'll not get C. So all these three are important. Okay. And step number 2. From step number 2, we found out that these are the FDs. Now from step number 3, we have to see if the left side is completely redundant free or not, which means this one. Can we remove A? That depends on finding out B plus. If B plus contains A, I can remove A. So what about B plus? It contains simply B, right? It doesn't contain A, so we cannot remove A. And what about this? I can remove B if A plus contains B, A plus contains A, so I cannot remove any of this, right? So this is the minimal cover for the earlier one, right? So this one has to be the minimal cover, so not this one, which means if here they would have given E, then that would have been the right answer, right? But anyway, this is the minimal cover, right? So for the given question, the answer is false. Okay.